where we drew out the little area of the rectangle, split it into 4 corners. This was our x squared, so we knew this was going to be x and x, so that took care of this term. Since this was a 2x, we knew we had to put 1x here and then another x right there. And that took care of this guy. When we add those up, that gives us that middle term. But then what we talked about is that would have meant we really just increased this by a 1 and we increased this by a 1. So this fourth corner in this model would just give us a 1. That's what should happen if we have a 1x here and a 1x here, which we have to because that's what our middle term is going to be. But if we look at the equation, we get a 1 legitimately in our model, but we need a 4 in the actual equation. So what we said we could just now do, what we had been working on is the idea that we could write this as x plus 1 times x plus a 1, or just write that as an x plus a 1 quantity squared. But when we do this, all this will give us is a 1. We wanted this equation to end up having a 4. So to go from this 1 to the 4, what we talked about is we need to tack on an additional 3 to the perfect square in order to produce the equation that we're working with. Once we have it written like this, then we can identify that our vertex is a -1, +3. All right. So it's just us kind of going back and forth between what we call vertex form, standard form. And once it's in standard form, we can put it into vertex form to figure out what our vertex is going to look like. So now, what this next page really is, so hopefully after we do a handful of these, we'll start getting this down, is just now mastering that idea, hopefully. Where this is standard form, so remember, this is what we call standard form. We want to put it into what we're calling vertex form, because once it's in vertex form, then it's easy for us to identify what our vertex is going to be. All right. So for the first few, we're going to probably draw out the area model, and then eventually, as we get a little bit better, you can think there's 6 of these. After we get through the first 2 or 3, maybe the last 2 or 3, you can just look at and probably come up with it pretty quickly. But for these first couple, let's go ahead and do it that route. So draw in the little rectangle, split it into 4. Look at the equation that you're given to work with. We know we have an x squared, so what that would have to mean is we have an x here and an x here to create an x squared box. Can you guys? No, it just died. Like, why did it just die? I wasn't even touching anything. It just went out. Like, the power went out. It's up here. I mean, the remote is sitting on the shelf up here. Ah, Cam. I don't know if I can do this all year. I'm losing my mind. Hopefully that'll warm up for you guys. My guess is you can look at your paper. Hopefully you can do those next couple boxes. So if it doesn't warm up, hopefully we can do that. If we go to that -12x, what that tells us is this had to have been a -6 and a -6. Again, we're talking perfect squares. That means everything has to be the same. So that means that this would have been decreased by 6. Is anything happening? No, great. And then decreased by 6. Just died again. You guys may have to pull out your Chromebooks if this isn't going to work. I have no explanation for why that just dropped out. Sorry. If this is now our model, so if this is our perfect square model in here, so we're going to create a perfect square out of this. For this to be a perfect square, what we would end up with for this term should have been a 36. The -6 times a -6 would be a 36. So when we rewrite this model, you would get y equals, oh, there it is. Okay, good. X minus 6 times x minus a 6. But what we're saying is we want to write that as a perfect square. So we can write this as x minus 6 quantity squared. When we do it this way, this only gives us this many constants. So currently, this here only gives us 36 of what we wanted. We want 40. So the fact that we want 40 and this only accounts for 36 right now means we need to add an additional 4 on the backside to get that equation to be the same as the one that we are dealing with at the top. Okay, does that make sense?
Yeah, it makes way more sense. I was confused yesterday.
Okay, good. Now we should be able to do the vertex, right? This is in vertex form. So once we look at this here, we've gone from standard form, where we can't really tell what the vertex is, to vertex form. We would hopefully then be able to look at that very quickly and say that our vertex is a +6 and a +4, 6, 4. All right. All right, any questions on that before we move on to the next one? The next one will make you think a little bit too. Good. All right, so letter B then, same thing. That's not a good sound. Any sound like freaks me out right now. Okay, we seem to be up and running. All right, so there's our square. We're gonna make it a perfect square. We once again just have the basic x squared right now. So that would mean this would have to be x, this would have to be x. Those multiplied together are going to give us that x squared in that box. The fact that the middle term is an 8x and we're dealing with a square, meaning everything has to be the same on both sides, that means we're going to put half of them here, half of them here, and that means we would have increased by 4 the length and the width. So what that now should do, think about what we would get right here for the perfect square. So fill in what you think that would give us. And then think what we need. Like, what are we going to have to do to what you're given and what we still need to come up with, and see if you can come up with that, okay? I can squeeze this in over here. All right, let's see what we got here. So in terms of the yellow box, if we knew this was a 4 up here, this is a 4 here, hopefully we would understand that for that perfect square, we would get 16 in that corner. So this equation here is currently giving us 16. Do we want 16? Is that what we have in this original equation? No. We need it to be a -1. So if I'm currently at 16, hopefully we all agree the 16 has to be decreased in order to get down to a -1. So we would decrease 16 by what in order for us to go from the 16 that this guy gives us to the -1 that we're supposed to get? Vicky, what do you think?
17.
Good. Now she's on the overhead. Fantastic. You sounded very, very cool just now, Vicky, in the classroom. I just want to say that. So then we're going to go ahead and do minus a 17 on the back end of that. That then is in vertex form. So we can now write the vertex as a -4, -17. All right. Okay, let's try one more with the area model and then see if maybe we can do it without for the last couple. So let's set up our square. We'd have our x and our x to produce the x squared. The -10x we know is a -5 here, -5 there. So we know we've decreased our length and we've decreased our width by 5. So now, for the perfect square, think about what it gives you in this box here, and think about what we actually would need. Okay, let's see if you got this right. We have two x minus 5s. So here's an x minus 5, here's an x minus 5. So you can write it initially as x minus 5 times x minus 5, but to go into vertex form, that doesn't look like vertex form. We just write this using a power as the x minus 5 quantity squared. So when we do this, this should give us 25. That's what it would be if it's a perfect square. If we have negative 5 on top, negative 5 on the bottom. If we want a 17, I'm going to call one of the two people in class. Either of you think what do we got to do, Cam? Good. We would have to subtract 8 away from what we currently have. This here gives us 25. We only want the 17. We need to take away an 8 from that. All right. Good. Our vertex then, 5, negative 8. All right. So now letter D. Hopefully, a lot of us seem to be, just by looks on our face, working, looking up, seem to be understanding this pretty well. Let's say we don't do the area model. So let me walk through this without kind of doing the area model and see if we can do these moving forward without having to draw a graph every single time, because that could be a little bit tedious. Think about your area though. We know we would have x, and then write what you think you would have now right here, x plus whatever or x minus whatever squared. Okay, without doing the area, I don't want to give you too much time for those who are drawing the area. Anybody think they know what would be inside of those parentheses right now? Yeah, Cam, I can't see everybody right now. Yeah, go ahead, Cam. Good. And how'd you get x minus 7, Cam? Good. So, good. That middle term here, this negative 14, is what we're splitting up into the two different boxes. They'd have to be the same. So they each have to be a 7. All right. Now, this as a perfect square then, hopefully we would understand that if we did that, if we think about what this lower right-hand corner would be, would we all agree that that would have been a 49 if we have a 7 and a 7? Okay, and if we need a 38, what do we have to do, Cam? Good. We'd have to subtract 11 from the 49 that we would currently have in order to end up with the 38. Okay. So then our vertex, the positive 7, and then the negative 11. Okay. All right, with that, I'm going to give you 3 minutes. Try E and F. E, I would hope. F, you got to think about it a little bit. You won't. Well, just try E, I guess. E is sort of the same thing. Yeah, just do E a minute. Actually, just wait a minute. Add a G. Let me give you one more nice one before we start throwing in fractions and decimals. So let's do this. So add a G. Let's do y equals x squared plus, we'll do 12x plus 11. And do G for me and figure out what that vertex would be. We'll do another nice one first. And then if you're confident in that and we're still waiting, go ahead and see if you can do the next one where there's a fraction or a decimal involved. Do one more nice one. crossing my fingers. Hopefully this one's pretty reasonable after having done a number of these at once. The first thing, once we know, we're going to do our x plus whatever squared to put it into vertex form. If we first look at this, if we did the area, that 12x would have been split up 2 different ways. So hopefully we would have had a plus 6. We would have 2 6s. All right, and then after that, we now need to understand what do I need to do on the backside to make sure that I get an 11. All right, anybody got that? What should we do to this equation right now as it currently stands in order to give us an 11? Brave souls out there calling somebody. Oh, is Ella hand up? All right, Ella, go Ella.
25.
Good. Plus or minus? Good. Ella says minus 25, which is good, because this 6 squared would have been giving us a 36. We wanted an 11, so we'd have to do 36, decrease that by 25. That would give us the 11 that we wanted. All right, good, Ella. And then that should now be a vertex of -6, -25. All right. Okay, now let's hop up to letter E, where you've got a fraction or a decimal. It's not a nice, perfect number that we can cut in half. And see what you think for E. If you have to draw it out, draw it out. Right now, it doesn't matter. But see what you think for this guy. And I would take either a fraction or a decimal. It's weird calling you Ella now. I always see you as Gabriella. I need a calculator myself right here. I'm imagining they're doing decimals. All right, same thought process, just it isn't quite as easy with some nice numbers, so you may need a calculator, especially if you're going to do this with decimals and fractions. So when we look at this here, the sign should be good. If we see that this is a -9, that would imply that we've got to be doing minus. What we've been doing every single time is taking this middle number, so like here it was a 14, we would cut that in half, that's how we get a 7. The one that we just did down here, we know we got to split that up equally into 2, that's how we get a 6. It doesn't change here, it's just not a nice number. We divide that by 2, so let me do one of 2 things. My guess is most of you write this as a decimal, so we would hopefully probably put 4.5 into the one square, you would have put 4.5 into the other square. There's nothing wrong with just leaving this as 9/2 either, like 9/2. Take the 9, cut it in half, you could write it as 9/2. So these are equivalent to each other right now. Then what we want to know is if I had 4.5 times 4.5, that's where I need to cheat also, so give me a minute. All right, so when I would do that, that gives me, so if I did 4.5 times 4.5, that's 20.25. That's hopefully what most of us got. What we need, though, is a -5. So if we're currently at 20.25, and I need to get a -5, I'm definitely subtracting, right? I definitely got to make this much, much smaller. All right. And was that your hand up, Ella?
Yeah.
Okay, Ella's got her hand up, so we'll see what she came up with. What did you have to subtract away to get a -5?
15.
All right, Ella says 15.25. What do we think? Agree with that? You're getting some apprehensive looks. Cam, what do you think? Okay, so let's look at Ella's real quick, because she's going to get 5 right now, so let's do this. 20.25 minus 15.25. But if I did 20 minus 15, isn't that a positive 5, Ella?
Oh, yeah.
Yeah, and we wanted it to be a negative 5.
Yeah.
All right, so she definitely got a 5. We just want to make sure that the sign is going to match up. So since we wanted it to be a negative 5, what did you say then, Cam?
Negative 25.
Yeah, let's switch this to a negative 25.25. Now that's going to give us a negative 5. So we would have to subtract that away on the back side, negative 25.25. Okay. Fraction's probably a little bit harder. Let's see this. I actually have to figure that out myself. So 25 fourth. Yeah, you'd be pretty good. You'd have to subtract 101 and 1/4 on the back side. So most of you, I mean, even for this one, I think this is probably easier. We want to deal with this as a decimal. And then we can write our vertex as 4.5 negative 25.25. Okay? All right, last one. See what we can come up with. Another ugly fraction. See if we can kind of work through that.
Here's like the way I always think about finding that the k part of the vertex. Remember, that's always take the negative 5 minus 20.25. Whatever my k is, I subtract what my constant is.
Whatever your k is.
So so for d, you had your 38, you got 49. You take 38 minus 49, you get negative 11. That would always work, right?
It would. Yep. Yep.
Okay,
we'll put that up. Yep. That's actually long term, the shortcut. If we add the 49 on the inside, just subtract it on the outside. Yep. Without once we completely remove ourselves from the idea of the area and all that. Yep. I can show with this nice number up here. A little space here. There we go. Didn't want to erase that one guy. All right, let's see what we got. We know this is going to be our x. Now that it's a plus 5, we're going to do plus. This middle term would have gotten split up between two different squares in our area, so we would have had to cut that in half. 5 divided by 2 is 2.5. All right. If I do this as an area model, we would have 2.5 times 2.5. That one I'm pretty sure I know is 6.25. That's what this currently gives us. We want it to equal a 2. All right, anybody come up with that yet? What would we need to do to get that to be a 2? Vicki, what do you think?
Minus.
You broke up just a little bit. Say that one more time.
Minus 9.
Yeah. Minus 4.25. Okay, we got that one correct. All right, now, to make it a little easier, so Ms. Krubowitz kind of pointed this out, so let's talk about it now. Let's go back to letter D when it's a nice number. Notice how if we have a 7 and a 7, that's going to give us 49. All we really have to then do is come up to this 38 that you had, and we have to reduce it down. We're just going to we added this 49, just subtract 49 from the 38. Notice how that's going to give you the negative 11 that's in our answer. If we go to another nice one, the 6 and the 6 make 36. If we just come up here and subtract 36 from this, doesn't that original value decrease by the 36 and give us that negative 25? So that if we did that now with the decimals when it's not quite as nice, the 2.5 times the 2.5 would give us this 6.25. If we just come back up here, decrease this constant in the original problem by 6.25, doesn't that then give us what we said our answer was, which was the negative 0.425? Okay, so whatever we're creating in that little square in the bottom right-hand corner. If you just subtract that away from that constant in the original, that should then give us what that answer is, okay, or at least the k value. Then we can write our vertex, which ultimately is what we're concerned about, so don't forget to do that, -2.5, and then a -4.25. All right, so hopefully that makes some sense, because we're done with all that now. I am planning to do a quiz on Thursday. So tomorrow I'll have something prepared, just a little review of all the stuff we've done. This will be a big part of it. You'll do a little quiz on Thursday. You also then have homework for tomorrow night. So if you have the task packet, look for where it says the extra practice. Wait, make sure this is right. I think that's what I wanted. Yeah, this is what. Where it says Ready, Set, Go 2.5. And you're going to do 1 through. You want it here? I think it was 2 pages worth. Yeah. Yeah, so just 1 through 17 on this page. So it's really these 2 pages. What pages are these in your packet? 19 and 20. If you don't have the packet, you can go to Canvas. Underneath assignments, I have just the 2 pages there, so you can just print off those 2 pages or just put it up on your computer and do those 2 pages there if you don't have your packet. All right. All right, with that, that's it. We've got 2 minutes left, so you guys are free to go. Just keep in mind quiz Thursday, and then make sure to remember to turn this in by tomorrow night. All right? Okay, see you guys. Have a good day. I did hit record, now I gotta stop.
Yeah, I don't know if it's just, start recording.